Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is episode 51 called Packet Protocol. Quick recap of what we've been doing. So basically, what we started a couple nights ago, I think it was on Thursday. Everyone... Oh, sorry, I'm mixing comments with what I'm supposed to say. I'm a little tired. Because I was up till about 2:30 in the morning after a 6.5 hour stream trying to get this thing to work. But it's working. And that's actually really sick. So, basically what we've been doing is using this extension port on the Virtual Boy. I don't think you can see my finger, but it's back here. We're going to use the extension port to make a serial connection between the PC and the Virtual Boy. And so, on Thursday, I started by trying to open the Virtual Boy and failing, just because I didn't have the right tools. But in the meantime, I was able to take my Teensy and get the serial example working and solder the pins to it and everything. So I was able to get serial connection to and from the Teensy. Yesterday, I decided to continue this, just because I think this is really cool and I'm really motivated to do this for some reason. So what I did then was we opened up the Virtual Boy because I got the right tools, mostly a drill to make the screw holes wider, and then some pliers for some other things. So we opened it up, took out the board that the controller and the external port was on, just looked at it and ended up deciding that the best way to do this would be to solder a bunch of these breadboard wires directly to the underside of that board so I wouldn't have to ruin the port. Because it'd be easy to remove later, just to desolder those wires from those pins, and then we could still use this with an external port if we get the right thing later. But for now, this is perfectly fine. Figured out how the pinout should look, hooked everything up, and then spent several hours trying to get the things to talk to each other. It ended up being that the protocol works a lot differently than I expected, which is fine. I kind of also expected that to happen. The main thing is that it's actually somewhat similar to, for example, I2C. So you have a master and a slave, and they both like, in order for a transfer to happen, as seen from both sides, they both have to sort of agree that a transfer is going to happen. But in reality, only the master just has to initiate a transfer, and it does so by bringing the control line. I think it was high. No, it's bringing it low. It brings the control line low, and then what happens is that it will then bring this clock line, which it normally drives high. It drives it low 8 times. So it'll drive it low, and then when it comes back high again, it'll actually read the data. So you're supposed to, when you see the low part of the bit, then you set the data, and then it pulls that up. So it's just a basic serial protocol. And after fiddling a bunch with the ROM on the Virtual Boy and this protocol, it ends up being pretty simple. So yeah, it just does that 8 times, and then we have our transfer result. Now, I've only implemented it so far as to actually read bytes. I mean, you can see the code here. It's really simple. This is like the whole thing. Actually, wait, you can't see the code. There we go. Here's the code. So these 2 lines here drives the clock high and then the control line low. Directly after that, we do 8 pulses where we bring the clock... We bring the clock low, wait half of a period, then we bring the clock high again, and then input a bit from the Virtual Boy, and then delay the other half of the period. So we just do that 8 times. And then we get the results, and we put it back on the serial port to talk to the, or we put it back on the USB. So fairly simple. The code for the test ROM was also pretty simple. We just had to write the registers the right way. And for some reason, I had issues because in the original library file for these registers, this was not marked volatile. And it seemed that I had to do that to make this work, which makes sense because we have a wait loop that waits on the value of this register. So I would have expected to have to do that, but maybe array indices don't need that. I'm not really sure why it didn't work. Anyway, we figured out the right bit combinations to send and receive to basically make the Virtual Boy a slave and also get the right timing on here. Now, there's a lot of things I want to do here to improve this. Like I really want to, I know we can crank up the time or the data rate that we actually transfer here. But I was thinking more about it, and I think the simplest way to do this is to, first of all, have this be bidirectional. So this should actually send at the same time that it's receiving. Very similar to the Game Boy link cable, if you guys have any familiarity with that. By the way, just so you guys can see this working, this is actually working this entire time I've been talking. It's been transferring bytes. So every second it transfers one, it totally matches. If I turn the virtual boy off, we get a bunch of zeros here. And then if I turn it on and we wait a second or two for it to warm up, then we'll start getting this AA pattern. And it works. So it's pretty sick. It seems to be pretty consistent. And now we've all got it working to where I'm basically just replacing software now. So I'm pretty happy about that. But yeah, so what I want to do next is, since this is a bidirectional protocol, I want to actually be sending bytes as well. So what I'm going to do is just have a byte that we increment every time we send, or every time we do a transfer. We're going to increment that byte, and then we're just going to display the value that we sent and the value that we received, and just do that with the teensy. I think the easiest way to do this by far is going to be to build a serial interface from the PC to see the teensy as if it were the port on the Virtual Boy. So as if the teensy can do a single byte at a time bidirectional transfer. The benefit of that is that we can move away from the teensy as soon as possible. If we have that simple interface and that's all it does, then we don't have to worry about like handshaking or anything on that level. We can just interact with that as if we're interacting with the Virtual Boy directly. And then we only have to worry about the ROM that's on the Virtual Boy and then whatever program that we use on the PC to communicate with that over serial. So then it's only those two programs, and it should all be fairly isolated. And then once we get, what I want to do with that is I want to get some kind of basic packet format. So I'm thinking that that we only have, like, the PC is going to be the master and the Virtual Boy is going to be the slave. So all we're going to do is have a simple protocol where we can send packets or request packets. And then the PC always drives that. If we have that protocol working, then we can basically implement anything. And also when we have that working, we can start doing things like sending random bytes, like random packets, random lengths and bytes, and then trying to echo them back. And then with that kind of setup, we can do a bunch of random tests and start adjusting the data rates to basically try and see how fast we can get it, which I think would be really useful to do early on, because that's going to make all the rest of our testing faster. And we should also do that when that's kind of isolated. So all in all, this has been a success so far, even though it's been, it was very tiring yesterday, but it was really fun. And it's really cool to see this starting to work. So next step is bidirectional transfer, and then hopefully get our way to a packet protocol. I've only got a few hours, which is a bit longer than I normally stream anyway, but I thought we could probably, assuming that this is actually working robustly, I don't expect it to take too terribly long to the next parts, because we can do it fairly predictably. So yeah, I'm going to get started. I don't think it'll be that cool, Skeleton. Because that's pretty cool. I also don't think it'll do as much like error checking and stuff. Because this whole setup is so basic. Oh, I bet people did that. Sounds like the kind of thing that people would do. So what I'm going to do here is we're going to do something here. Actually do it up here. So what I want to do here, we're going to bring this low, and then what I want to do is send the bit. like this. And then, so the way we send the bit, we just need to do the data out, which should be easy enough. I think we do that for the data out. And then we're going to do the sent byte shift. No, we do MSB first. So it's going to be shift right 7 minus I. And 1. And then we're going to shift that left by 3. I think that makes sense. We'll know soon enough if it doesn't. So yes, that should work. That would be the teensy code, and then we also need to update the ROM. I'm going to do that first here. So right now this transfers AA. I want to change this a little bit. Set this up as initial transfer value because why not? Just going to remove this other crap here. I'm going to do a single byte transfer here. And so what we want to do is we want to send the... We're going to do a single transfer. And then we're going to set the send value to whatever we get as the receive value. Which is this one, CDRR. I'm thinking that the VB won't be able to initiate printf transfers. I think most of the protocols that we want to design are going to be based on sending some work to the Virtual Boy and then pulling some data back. If we need to do printfs, then I could do some ping stuff with a buffer. But I don't think we'll need to do that because that would make it more. Like I don't know how to make the Virtual Boy initiate the transfers without like explicit control of the control line. I'd rather just do that from one end. But I mean, if we need that, we can just ping at a fixed interval. So this should be enough to do loopback. So let's build that first because that'll take the most time. The other thing I'm going to do while that's flashing is this waiting for the Virtual Boy to power on doesn't really make any sense, actually. I don't think that's something we need to wait for. So we can comment that out. I think that'll be fine. With the teensy ROM, reflashing that's really nice and easy. I'm still doing just like printf from the teensy to the machine, and that's just fine for now because it's easy to test. Oh, I messed up the printing here. Right, I need to print out the inline characters here. It should be safe to just always try to communicate with the thing, as far as I understand. Yeah, this actually doesn't check anything for the Virtual Boy, so let's just even comment this stuff out. Make it as lightweight as possible. Okay. This is fine for now. Oh, I also forgot one piece of this, which is that I was going to increment this. So that way it'll send different bytes every time. Right, so now we're sending increasing values, and we're receiving nothing. Now I'll turn on the Virtual Boy, and we're going to get an AA value, and then we should get the same bits as this plus 1, and we're not, so something's wrong here. But this is cool, I think. Hello, Luxemtex. It's weird that we're getting all ones here. But you know what I actually think it is? I don't think I have the data direction set up for the output port. Or for the output pin. On the teensy. So let's try just changing that. That should do it. I don't think it'll be more complicated than that. But that would make sense, because then if it's always receiving ones like that, would make some sense. Boom! Guys, look at that. Oh, that's beautiful. I'm so happy that works. Oh, that's so sick, you guys. It's so satisfying to see that work on like the first try. Maybe not the first try, but with such low effort considering all the crap yesterday. They're friends, guys. Finally. Second first try, exactly. I like that way of looking at it. So I just turned off the Virtual Boy, and I'll turn it back on, and we should see again the same pattern. It'll send an AA byte, and then it'll start echoing. Oh, so cool. I'm just going to wallow in this for a minute. So the next step of this is to do exactly the same test, but instead of having the teensy be the driver, I want to have a Rust program be the driver. And I want to have it do exactly the same logic, but it's just going to, the protocol is it's going to send a byte to the COM port and then read a byte from the COM port. And that should simulate this exact same behavior. And once we have that, then I basically don't have to touch the teensy code again. And we're only working then with the Virtual Boy ROM and the Rust program, which I think will be pretty cool. Yeah, I think that's a good way to do it. We will want to touch the teensy again later, though, because it does do these delays, and we do want to adjust those. Zokwar, for the error stuff, that's what I want to do when we have the Rust driver. Because that should be able to, like if it's sending and reading stuff, it should also be able to detect errors. And once we have that framework, then I want to start doing things like setting a bunch of random bytes and seeing how fast we can get it. and some other things. But that'll separate out the layers really nicely. So the teensy just becomes a transport layer rather than another thing we have to make a protocol for, as it were. I mean, we still have to do that, but it'll make it as thin as possible. But I definitely want to do that when we start pushing the data rate. I want to like try to send a bunch of things and see what goes wrong. But I don't want to do that in the teensy. Oh, this makes me so happy. Oh, this is really satisfying now. I know people were pushing, I think it was 250K bits a second. So between the USB and the teensy, I have 9600 baud. But then between the Virtual Boy and the teensy, I think that's 50K baud, something like that. What's 20 microseconds? And is baud bits per second or bytes per second? So assuming baud is bits per second, then I have 50K baud between the teensy and the Virtual Boy, which should be able to go up, and then I have 96 or 9.8K baud or whatever. So these are the things that I need to hammer down on a bit when we get the stuff working first. The way I'm going to do it is I'm actually going to explicitly measure. So we're going to send and receive stuff as fast as we can with 100% correctness to and from the Virtual Boy. So if it's symbol per second or pulses per second, then I think calling that bits per second in this case is actually appropriate. I guess we could call it bytes per second eventually, but we'll see. And in this case, the numbers that I was saying should be accurate, I think. Anyway, so all we need to do now is communicate with the COM port. I actually don't know how to do that. I just search Rust COM port. So I guess there's a serial library. Here we have documentation. I want an example. Here's an example. Cool. Thanks, Love Like Semtex. Yeah, then it's 50K baud, and it's 9600 baud between USB and teensy, and 50K baud between the teensy and the Virtual Boy. And I know we can get both of those a lot faster. But I'm going to set up the whole pipeline before we start pushing that. Because what I expect to see is that what I want to do is set up the Rust thing and then just go as fast as we can get that to go. Where we synchronously send a value and then wait until we get a value back. And then that should show us that we're getting 9600 baud. Because that should be the bottleneck, I think. But this looks pretty straightforward. I think we just open COM4 with this. At least on Windows. Since we can set the baud rate here too. That should work nicely. Actually, how do we do that? Teensy set baud rate. Okay, it actually says data is always transferred at full USB speed. This is merely a setting selected by the PC or Macintosh software, which is not used by USB. You do not need to constrain your transmission to this rate. However, many serial communication protocols are coded very inefficiently because the programmer assumes slow data. You can easily overwhelm these programs even when running on very fast machines if you sustain full USB speed transfers. I don't really care about that as long as we're getting, like, we're basically doing handshaking per byte, so that shouldn't be much of a problem. Yeah, because USB also buffers the data, so. Sweet. Yeah, when no errors occur. That's actually nice. So then we actually shouldn't see that as a bottleneck. We should actually end up seeing the 50K baud between the Teensy and the Virtual Boy as the bottleneck, which is ideal because that's less things to tweak. In fact, that's only this code here to tweak. And that's really cool. Being able to run this as a master to communicate to the Virtual Boy is actually really nice for this use case. So yeah, let's try to do this. The first thing I'm going to do is just write a program that's doing exactly what Putty's doing, because that'll just be it'll be easier to just swap this piecewise. So I'm just going to close this. And we'll make this Rust program. Projects on my hard drive are a bit scattered here, but this is fine. Hey, Pyro, I might be then. Our cargo new -- bin. I don't know what to call this. I mean, it's probably a test program for now anyway, but. Xver. What? Cargo command not found. What? Something messed up my paths, you guys. Oh, I bet it's Dashlane again. They always mess up my paths. Okay. That's super annoying. Okay, I gotta fix that then. Oh, that really grinds my gears. Makes me so mad. Oh, I am so displeased about that. Yeah, it should work if I just reinstall Rust up. Oh, that's so annoying though. Because that's definitely not the only thing in my path either. All that's going to be messed up, but I'll just fix this for now. Oh, I'm fuming right now, you guys. That's my least favorite thing. That is a good idea to check, actually. Or is it CMD, I guess? No, there's definitely stuff missing in my path. Erg. Why is that window that big? Who wants that? Also not what I was looking for. Yeah, I think it was dash line because it did that before. And yeah, my user variables are all messed up, not the system ones. Okay. Anyway. I gave Dashlane a lot of shit for that last time. Should probably give him more shit for it. That is quite unacceptable. Okay. Breathe, Jake. Breathe. Just install Rust, it'll be okay. Do it. Do whatever you have to do. Wait, what? What the hell? I thought that was going to make it happen. Did it not? Oh, Rust is already installed. Okay, it looks like it also didn't actually reinstall. It just did what it had to do, which is nice. So, good job, Rust up. Bad job, whatever fucked up my paths. Oh, that makes me so mad because there's so many things that I put in there. Okay, anyway. It's going to be like days before I'm over this, you guys. So X for test. It's going to be right here. That's where I put it. The serial crate looked just fine. So go ahead and nab that. I'll send some angry letters to the Virtual Boy. But it'll just send them back right now. Then I could do skeletons, since I'm using MSys most of the time anyway. I could probably do that. But I'm not gonna deal with that right now. I'm just gonna be mad about it. So I'm just not gonna do any of this with reconfigure. I'm just gonna open the port. And just read stuff. Because let's just try that. Yeah, we'll see how sane the defaults are. We'll find out pretty quick here. So we'll do... Try that. Or is it 256.0 like that? And then let's do this. Yeah, they do against my theme. They look pretty bad. I think we just read with mute buff. I think we can just do that though. Don't need to specify the whole range. Dot unwrap, because why not? Yeah, we need stdio read. And we just need to buffer this to std out. And so if we do this, oh, whoops. Apparently this wasn't used. Okay. Operation timed out. I'm guessing that was on the read. Yeah, because it seems to have connected. So let's set our timeout then. For, do I have to specify something here? Quotes? What for? I mean, we should just be getting raw bytes, although we will get a lot more than we asked for. We need to know how much this read. I think the new lines should come from the bytes that we read. That's what I would expect, at least. Might be that we need those, though. So in this case, system port should at least have the interface that we need. Set timeout. So I can't just set this to a lot. I mean, it should be basically instant anyway. So if I do set, I need duration and stuff here. Then we'll just do this. Yeah, now we need this stuff. And we can unwrap this. Oh, nice. That is actually nice. I like some text. Okay, so there we still timed out. Let's just bump this up to see what happens. That's going to time out. So maybe we need to configure some of this stuff. We definitely connected to the right port because when I pushed the button on the TNC while reading this, then it crashed saying that the connection was terminated. And that's fine. But I don't know why we're unable to read stuff. As far as I know, this is just putting bytes onto the USB serial. So reading should have given us those bytes. Also, Tokyo has some serial stuff. But it looks like their example was doing the same stuff, but they also explicitly set the settings like it did in the serial thing. You know, that might actually be Daniel Cullen. That's a good point. Although it's still failing. But I do actually only want to read one byte at a time at this level anyway, so I think that's correct. So let's try both. Kind of weird that this takes a lambda to reconfigure this. We'll try it. Still nothing. Yeah, I'm not too worried about that. In the future, I'm going to replace this anyway, so I just want to be able to cat the stuff that we're getting on the port for now. But then we'll turn this into a binary protocol after that. This should synchronize anyway if we do it like that. So what is happening here? I don't want to suspect that it's the library. I don't think there will be anything else using COM4, because that would have been a problem when we had PuTTY using it. For example, if I just try to do that with PuTTY, then we're getting stuff. Only Unix-based platforms, so that doesn't work anyway. But I did kind of want to see how they were. Whoops, wrong thing. I was hoping to see an example of that, but if it's not going to work for us anyway, then why bother? Let's see. Yeah, I suppose I could try and test this with something to make sure it would work. I don't know what I would test this with, though. So it should work if I do COM1 like this, or COM4 in our case. Looks to be all the same settings here in this just rewrite example. Sure be dumb if that fixed it, but yeah, that's definitely not it. Yeah, about looks the same. What if I, just to make sure I got the right port, I'll disconnect the teensy. And then this should fail because it can't connect. In this case, can't find the file specified. So it is connecting, it's just the transfer is not working. Bit odd. Okay, there's another serial port -rs. Thing is, I'm not necessarily looking for a different library to use because I think this one is busted. I'm looking for any clues that we could configure it differently or something else. Oh no, I'm digging into other stuff, Daniel Colin. I'm not looking at that source at least. So this one may work is when under Windows. But I want to see an example, please. Sudo terminal. That sounds relevant. This is basically exactly the same code I have here. I'm actually going to try this with the serial port thing. Just to try. One, it looks like the docs I'm looking at least. I don't think that'll help because we have a 10-second timeout. So I doubt the first one is just supposed to fail. Doesn't make much sense to me. I know unwrap sucks, guys, but Give me some credit. This even tells you how much it read, which is nice. We do this too. Yeah, all this is going to be wrong now too. Same with that. I think. Now this did say Windows was tier 2 support, so this may not work anyway, but oh yeah, it is timing out on read file there. So this won't unwrap, but yeah. I could use WinAPI directly, but I'd much rather use a package that'll provide cross-platform support. And yeah, that's what the code should do. Something is strange here. This is nice to sleep a little bit. Let's have it do that too. Why not? Why can Putty do this and we can't? What's different there? Oops. Again, it's create file. And read file here too, so basically the same code. Because I'm guessing that file is essentially just creating a little buffer there. And then when we try to read this, we're just reading whatever bytes are in that buffer, and if we read those, they get consumed or something. Getting lost in tabs here. I still think it'd be weird if it were a naming thing, just because like it would fail to open the connection rather than fail to time out when reading from it. But I could try that. So there's one port, and it was COM4. That's good. So this getting this error didn't help us much. Hey, MSys. We can do this open with settings thing. Could just try doing this directly. Still nothing. That's so strange. How is Putty able to do this? I wouldn't expect increasing that timeout would help much. I mean, can try. But I don't think that's the problem. I think something else is wrong. Yeah, that's the thing, is it should just be reading like as often as it can. I wouldn't think you would need to write something first, but maybe you would. That would be annoying. I think you do that. It didn't seem to help. Yeah, the right worked. Maybe there's something teensy serial port settings. That wasn't that helpful. The teensy should definitely connect. Like, that's why putty worked. And the USB in it and USB configured. It does wait for host to set configuration, but I honestly would think that that's just configuring the USB part of this, not necessarily the serial stuff. Maybe we need to do this. Wait for user to run their terminal emulator program, which sets DTR to indicate it is ready to receive. Maybe that matters. I just search serial port set DTR. Is there something I need to do in the library, for example? Open, this will give me a serial port. Do I need to set DTR on this or something? Oh, here we go. Write data terminal ready. So this is waiting for that to happen. That could make sense. So let's try that. Let's try taking this serial thing here. Needs a level. Okay, that's it. Okay, at least it was something that made sense. We're not getting crap back yet, but that's because I haven't turned on the Virtual Boy. And then this should work. Nice. So that's just straight up me not knowing how to use TTY. But that's fine. Yeah, it probably would have worked with the other library, but this should be fine. I'm also going to try doing this again without setting these settings, just to reduce the amount of things we do here. Yeah, we're still good. That was cool. It sent the last value from the Virtual Boy. Hey, Mr. Tobe. That's cool. So now what I want to do, I want to get all of this happening just from Rust. So what I want to do, we're going to change the teensy program. So it's not going to send like anything. We should probably handshake though. I would expect at least that we should do that with the teensy. And that'll be a good test anyway to send and receive. So let's do that. Let's make sure we do the handshake first, and then we'll have it do its normal thing. So we'll do stepwise. Continue that. So wait for data terminal ready, and then, yeah, that's what we're going to do. So we'll send data terminal ready, and then we'll expect this to send something back, and we'll call that our handshake. I think that's good enough. Let's just send VB okay. As a string. Actually, I really want to send like an integer. Although doing a string is fine. Let's actually just do that. Let's send handshake, yo. So we'll send data terminal ready. So here, isn't there a read? I think we can request to read a specific number of bytes. Yeah, read exact. That might be a bad idea. Oh yeah, let's do that. And then I think I want to split some of this stuff out here. Ugh. Why can't I type? This probably comes from the prelude. I know this will be crap that I'm not doing like unwrap and stuff, or that I'm doing unwrap and stuff here, but this is just gonna be fine. Serial port open gives us a box, doesn't it? That would make sense. Then we have dynamic dispatch on this stuff. Yeah, that would do it. Yeah, I'm prototyping. Matt RVA, thank you so much for the subscription. Whoa. Something like I think you do that. And then I want it to read all of this stuff. And I don't think we can, I think the reason I want to do this is because I think we need to do this loop. Is buff reader what we need here? So I think I'm worried about reading too many bytes when we do this, like in the loop here. We want to buffer those somehow. But we need to both read and write here. So maybe we just have to deal with that ourselves. Then again, read won't ever read more than you ask for, will it? Yeah, if the return value of this function is okay, it must be guaranteed that n is not as much as the buffer length at least. So I don't think we need to do buffering that's too fancy here. Or yeah, we do, because we want to buffer out a read. Whoops. There's this many bytes. Because here's what we'll do for the handshake. We'll do something like this, and then let mute handshake buff is vec. I think that doesn't work because it might need to be a constant function. It might be okay though. Although I'm probably getting these arguments wrong again. Yeah, we'll do this. And then here we can do ret.blocking read handshake buff. And then we need to check if these match. I think we just use slice equality. I think these implement EQ. Oh, they have equality for all the different lengths, which is really shit. But actually does have enough overloads to cover what we need here. That's kind of funny. Oh, do this. Writing too much C. So this is wrong, but I think this logic makes sense. And blocking, I mean, we're going to just wait until it finishes reading that many bytes. That with a timeout is going to make a lot of sense. But for now, I'm not going to worry about that. I think we're going to get pretty far without worrying about that, to be honest. So X is also wrong. We don't want to write that out. We do that, and then we start reading at that offset here. And then we can do read offset plus equals num bytes. If read offset is equal to buff.len, then we can break. And then here we probably want to sleep a millisecond or something. Oberst Kruger, thanks for the follow. I think read exact actually is what we wanted. think I may have made this preemptively. Although we'll see, because this may not work, but yeah. Just bear with me, guys. Cyclical, thanks for the subscription. Not used to saying that. It's a party up in here. Now we're getting timeouts. Then we get the wrong data. Did I rebuild this, by the way, when I did the handshake? I'm not sure I did, actually. Yeah, I'm kind of not keeping them on stream. Somewhat on purpose. Okay, so that actually worked now. I wasn't actually sending the handshake. But let me just see if read exact actually can do this. I got a lot of windows, you guys. Again, just bear with me. So that didn't work, but I guess it might be because we didn't reset anything. Yeah, okay. So we actually get timed out if we do read exact. So we do need to do something like this. I think, though, what I want to do here is simpler. I think instead of wrapping all this up, I just want to do something like this. Do that, or is it that you do to get it out of there? Is it that? That's what it is. We can make our own trait and then make serial port implement that trait. Would be a way to do that. But I'm gonna do this. I don't think we need this struct here. I think this might just be read, actually, for what we want here. I don't know why I would need that since we're only taking references here. Well, that'll do it. Nice. So this definitely works then. What I'm noticing here though is that it's not really detecting like when I disconnect or reconnect from the program. So if I run this again, it won't work because it tries to get the handshake, but it actually just gets more data. So I want to see how we do that on the Teensy before I move on. Teensy USB serial reconnect. Yeah, I think actually too. This probably actually won't be that big of a deal. Because we're going to wait for things to be configured, but then subsequent, like if I reconnect this, it seems like we're getting good data. So if I just wait, like if I just do, since we're going to be doing a protocol per byte anyway, maybe we don't need this handshake at all. We could make the handshake part of our like byte protocol too. Hey, Pyro. Yeah, we're still going. Not much. We got Rust communicating with the Teensy. So now it's a Rust program that does this. Yeah, exactly, Zokwar. And Chief Detector. So let's actually just try implementing the per byte protocol without the handshake. Just try this. We are still going to want this blocking read function. We're going to make it read 1 byte. So in this case, the protocol gets a lot simpler. And we may want to do some stuff with reconnection as well, but we'll figure that out in a minute. I think all I want to do for now is we're going to grab a byte, which should just be, because this was doing that in some of the example code, USB serial get char. So this also did reconnects here, it looks like. Oh no, it just quit. Yeah, because USB serial get char can fail, and that's going to return -1. It breaks out of this loop. Okay, so this is actually easier. So what we're going to do, it's all the same, isn't it? We'll wait for USB to be configured, and then we wait. And here, like this. So here, oops. What did it do here? In 16 is get char. Also, for these chars here, I actually really want to be using these ones. Uint 8t's, because that's better. So we're going to be doing essentially the same things here. That's what this is doing, Blind Bear. I'm going to do that just because I know that's what this is doing. I'm just going to copy this, actually. Or, yeah, copy this here. If yeah, we will do the handshake here. Because why not? It's cool to do the handshake. Oh, not uint, right. So in 16t, yeah. That's the part I messed up. You're absolutely right. So but yeah, other than that, do that. So then we do the transfer, and then we should just be able to send the received byte back. Received byte here. That should basically be that. Reprogram that. And now here we want to change some stuff. And we can do blocking read on R and buff. I think I did. Because that breaks out of this one, which is internal to the connection loop. So I think we're good there. Although there was another condition here that we needed, which was the timeout here. Right, because here we have this condition. So if it's this, we can continue there. Maybe I can make this a bit clearer, but I'm not going to worry about it for now, as long as that looks correct. So now what I can do Really? Probably doesn't know the type, actually. We'll get to that. Yeah, it's also all we need here. Then we can do send the byte. So we'll do port dot write. That, and then we can do print line. And I'll do this as string 08B. Hey, Graham. Oh, that's sexy, you guys. Oh, that's actually so cool. Do you realize what's happening? Let's see if I can reconnect. Oh, baby. And we're still getting residual values from the last run, which is actually correct. Oh, this is actually awesome. I was really hoping we could get at least this far today. So what we now have is we have the teensy acting exactly like the bidirectional extension port of the Virtual Boy and communicating to the Virtual Boy. So we're getting bidirectional transfers here, which is just really sick. And in fact, we can wrap this as well. Or here we actually need the port. So we'll do this. We'll do VB transfer, where we give it a byte to send, and then it will give us the byte that's received. It's a nice signature. And then this is easy, because we really just do this. Whoops. Should definitely do that. Really don't understand why it needs a constant size for that. Yeah, let's do this though. I think that's the syntax. And then we can just do mute port here. Oh, come on. Or is it plus that we use here? I can't remember the syntax. Yeah, that's what it is. There we go. Nice. Oh, this is so sick, you guys. This right here is the dream, to have this one function. I'm going to remove this comment as well because we don't need it. Pretty obvious what's going on there. Oh, that's so cool, you guys. So the next thing, actually, what I want to do is see how fast this goes. Because with this setup, or actually, no, that's not what I want to do yet, because we do want to be able to send and receive blocks of data, and I want to do that before I mess with the data rate. So So I'm also going to make this VB byte transfer. VB transfer byte. Let's start a fire by overclocking the Virtual Boy because the mirrors oscillate too fast. So I was planning to leave at 4. And if I have to be realistic, I don't think I'll be able to get bidirectional packet transfer done in that time frame. So I might call it quits here today. I think that's what I'll do. While I'm here, though, I'm just going to remove a lot of this other code. We don't need this other command interpreter stuff either from the original example, as far as I know. Okay, so it is doing send str. Yeah, okay. We did use send str to for the handshake. I have some ideas for the protocol. It's gonna take some iterations though, for sure. There. I'm really happy with this code. 100 lines of code, given the standard library stuff. And that's enough for the teensy. So now if I push the button on the teensy, it'll reprogram, and it'll break the Rust connection, which is exactly what we expected. And then now it just works again. Oh, I love how robust this is, you guys. Although I can, right now, just make this faster. That should be no problem. In fact, I kind of want to do this. Sweet. JNI. I don't know what RMI is, but I'm guessing you're being facetious. I mean, this looks great though, you guys. Uh-oh. Okay, failed there. I wonder why. Not a problem. All right. I bet this wouldn't be a problem if we weren't printing, to be honest. Okay, maybe it would be. That's fine for now. Or actually, while I'm at it, I could add retries for this. Ugh, too much C. Sweet. Oops, I wanted to print the stuff. Oh no, that should still happen. Ruh-roh. Oh, I know what's happening here. And this is what we want to take out. And this should be robust now. Or not? Yeah, I guess we would actually need to reconnect. So I think actually what we want to do here is instead of waiting for the handshake, I think we want to, if the handshake fails, we want to reestablish the connection. Yeah, I think you're right, Blambear. So let's do it this way then. Actually, we'll do result here. This will be fine. It's cow out that I want, isn't it? Screw it. I'll just do a string. I don't want to deal with this. Prologue? Or am I mixing that up again? I typed it like 5 times today. Prelude. Whoops. That's the wrong terminal. Oh, whoops. Yeah, good call. That'd make more sense. Now this should be pretty robust. Oh, this is rad. So sick. Just for fun, though, why don't we just try to bump this down here? Should make it twice as fast on that end. I still want to do like proper tests with correction, like checking for correctness and stuff, but I mean, just eyeballing it, it looks pretty good so far. That's so cool, you guys. Something extremely, extremely satisfying about all this. About using modern hardware to talk to old hardware like this. Yeah, I totally am. So what I'm thinking for the protocol, I thought a bit about it. First of all, there's a master, which is the PC, and then there's the slave, which is the whole teensy Virtual Boy setup. As far as we're concerned, we can kind of ignore the teensy now, other than when we adjust data rates. But so we have the PC and the Virtual Boy. And what I'm thinking for the protocol is that the host will always initiate communication, and it will either send a packet or receive a packet. The packet format, so there's going to be a little handshake for that, and then there's going to be the actual data for the packet. So I think that we're going to be able to do a handshake for when we want to start the transfer, and then that will also establish the direction that we want to do the transfer in. And then once we have that, then we have, I think, like a 2 or 4 byte number, depending on how big I want this to be able to be, for the length in bytes, and maybe even 1 byte, depending on how we end up getting this to work. Because it may be that we want really small buffers on the device for sending packets, so it might even be a 256 byte buffer. Anyway, so it'll send the length, and then since that length has a guaranteed size, we would be able to do that safely. And then with the length, it will do that many transfers in either direction. And then at the end, we can do a checksum of all of that information, including the length. That's what I'm thinking, because I think that would be really simple to implement, and that would definitely be enough for us to do what we need to do. I don't think the protocol needs to be more complex than that. But when we get that working, then what I want to do is implement a basic protocol where we can, when we have packet sending, I want to implement a test ROM that is going to give us an interface from the PC to read or write regions of work memory, or just regions of the memory map even. And then we can generate random tests with that, where we will read a block, check its contents, write a block, read it back again, check that it changed to what we expected. And do that with just a bunch of random blobs. And from there, we can start doing things like when we get 100% that this is working all the time and it's robust, then we can start adjusting the data rate. Yeah, FNV would be perfect because it's so simple. Just something stupid fast. And the Virtual Boy CPU is a 32-bit processor too, so FNV in particular would be really convenient to implement. So yeah, I'm just thinking like there's the handshake byte, and then or a couple bytes, I guess it'll have to be. And then once the connection's established, then they'll send the length, and then the actual data of that length, and then a checksum at the end. I honestly expect us to be able to make something quite robust out of this. assuming that we don't have to worry too much about like, oh, I unplugged the Virtual Boy in the middle of a test or something, and then I'm just like, screw it. Let's just restart everything. Speaking of which, let's just unplug one of these. No, let's not do that. I think that I'm going to go, though. But I am super happy with this. That now the Teensy is basically transparent in all of this. Nice cheap sticker. Yeah, Blambear, the first thing we could do is check if they're received as the old sent, but I want to actually just wait until we get, like, because this looks visually correct to me, so I'd rather wait until we get sending more bytes before I spend time checking that stuff. Oh, that's cool. That sounds like a really fun project. But yeah, thanks guys for hanging out. Tomorrow will be probably demo scene stuff because I want to work on our demo tool. But if earlier than that, than the normal plan one, I want to stream on this some more, then I will. So we'll see. Yeah, no promises if I'll do this tomorrow, but I might. I mean, I have, because I'm actually going to a concert later, so I might not be in a very good condition tomorrow. So we'll see. But yeah, thanks guys for hanging out, and I'll see you next time.